How do we quantify fluid behaviour? Viscosity is the most important property affecting flow behaviour of a fluid. It's determined by relating the velocity gradient in fluids to the shear force causing flow to occur. Consider a fluid sandwiched between a stationary plate and a moving plate. The absolute value of the velocity gradient is also known as the shear rate. The shear force we apply is directly proportional to the velocity gradient. The shear stress causing fluid motion is equivalent to the force per unit area, and therefore the shear stress in a fluid is directly proportional to the velocity gradient. We can rewrite the proportionality as a direct relationship between shear rate and the velocity gradient to give Newton's law of viscosity, where mu is the viscosity. It can also be written in terms of shear rate. Viscosity is therefore the relationship between shear stress and shear rate for a given fluid. The units are Pascal seconds or Newton seconds per metre squared. The viscosity of water at 20 degrees C is about 10 to the minus 3 Pascal seconds, or 1 centipoise. We can interpret the flow between parallel plates as momentum transfer. The fluid in contact with a moving plate acquires a velocity and therefore momentum in the x direction. Some of the momentum is transferred to the adjacent layer of fluid above it, which is also set in motion in the x direction. Each successive layer of fluid is dragged along by the viscosity. Momentum in the x direction is thus transmitted through the fluid in the y direction, from regions of high velocity to low velocity. In this interpretation, shear stress is considered as the momentum flux. The velocity gradient acts as the driving force for momentum transfer.